Hello, so this is going to be the demo for the Project 2 programs. So I have the two basic ones, ping and circling, and then I choose to implement p-hold. So just going to kind of take a look and explain each program itself before running them. So for the first one, the most simple one, ping. So for all three of these programs, I implemented the command line that parses in the flags and the necessary arguments needed for the functions. So all of that's parsed in and set to global variables to be used in the simulation. Alright, so the main, for ping, it's pretty simple. Basically it bounces a message or the ping between ping and pong, like a game. And so what I did to kind of implement is kind of like two functions that bounces off of each other. So first you start off with RT is going to be the variable keeping track of the number of trips. So you start off with running the environment and then starting the process of ping and running it from there. So what ping does is going to determine first for the latency if it's going to be fixed or if it's going to be random. So if it's fixed, I have it set to default value up here, which is 2. It's going to be 2 for default for all three programs. Otherwise, if it's random, it's going to choose a random number between 1, the floor, and whatever the max latency value is set to as. And then it's going to yield, wait for however long that latency period is before it's going to call the corresponding process, Pong. And what Pong is going to do is basically it's going to update the total number of trips variable. And then from there, it's going to go back to call ping, and it kind of starts this process over again. So it goes back and forth until simulation time runs out. And it's going to output the result at the very end. So to run, starting off with the fixed sign. So here the result was 499, with the latency being 2 seconds. So it's probably 499 because the 500th trip I concluded right during the simulation time, and so it was waiting all the way up to simulation time ended, and then before it could update it, the simulation terminated. Now to do the random. Oh, okay. So for random, it's probably better if I set the upper limit to something a bit higher. Okay, so for random, the value is smaller than the fixed value of 2. This kind of makes sense because the longer the latency, the less trips that ping will be able to make from ping to pong, and so the value is less given the same simulation time period. Next, moving on to circling. Circling is essentially really similar to ping, just added a bit of the only thing that was different, I believe, was kind of like modeling the kind of like circling behavior, a move from the sequential LPs from 0 to 1 to 2 and back to 0. So so everything is the same compared to ping, except that I got rid of pong and just have it start pinging other LPs. So in this process here, what I have to model that behavior is this destination LP variable, and that's going to be set as another parameter for the whole process. So this parameter is going to I have the modulus by the total number of LPs, so that way as the program runs through the simulation time, it's going to cycle between all the different LPs and have that value to indicate which LP it is going to each round. But everything else is the same. It's going to determine if it's fixed latency or if it's random, calculate that, and it's going to yield before updating the RT or the total round trips. The other thing, and it's going to call back itself as like a recursive process. So the other thing that was a bit different was that I noticed that like the output, if we're just counting the total number of trips between processes, it would be essentially be the same with ping. So I kind of outputted the round trip as well to kind of like differentiate the output a little bit. So now to run it. Alright, so here it's going to be total trips 499, the same as before, and the round trips with 3 OPs will be 166 round trips second. And now for the random latency, and it's kind of like same there. Less total trips due to larger latency. Alright, lastly for p-hold. So for p-hold, the main additions that had to be made was the logic there with the scheduling of the messages. Had to set up a queue for that. So for the queue itself, it's set up with the initialization of all the variables from the command line there, and then over here it's going to be the actual priority queue. So I use like a for loop to kind of just generate however many messages and insert them into the priority queue. And then kind of same thing with the recursive function that we use in circling. I believe for most part it was all the same. It's just that from in here I also have the message as a parameter. So there's the next item, which is signifying the next item in the queue. And that's going to be the message. And then from LP, same thing with circling, saying which one from which LP this is message coming from, and then to which LP this is going to go. And then so that's going to be implemented there for basically when counting the number of trips. If the LP is sent to itself, then that trip is not counted. So this if statement is actually taking care of that. If it's equal, destination is equal to from, then if destination is not equal to from, then it's going to count and break through this while loop. Otherwise, if it's the same, it's going to keep on generating a random location for the LP until it's like a different one. Going down here, so this is where the central loop is going to be for running the whole simulation. So here we have a number of variables setting for the count message sent, as well as the from LP. Okay, so for the count, that's going to be the main condition. So while the priority queue is not empty, while there's still messages in there, then the simulation will continue to dequeue and then schedule these messages to be sent from the LPs. And to kind of model the make sure that all the LPs send the same number of messages, that the messages are evenly distributed. I did like a simple if statement in the while loop. It's pretty much similar to this circling, how I implemented the for the trip to be taken from the sequentially, so from 0 to 1 to 2 to back to 0. So it's the same idea here. It's going to use modulus with the total number of LPs to evenly divide the messages so that they're sent from different LPs equal number of times. So it's going to keep on circling and then doing that, assigning messages to these different LPs until they're all sent. And then that's just going to log all the different messages as they're bouncing around from the LP to LP until the simulation time is over. And it's just going to output the total. Okay, so starting off, so this time I'm just starting off with the random. And then that's the value for the random. Then now if we're to fix the latency, And for the fixed latency, I had it set for 2 here as well. It might take a bit longer to run since like it's Behold. And then that's the value for Behold. So for the fix with it being 2, obviously it's going to be a lot more trips with the latency being so short. While here with the random being set, the ceiling being set at 100, then the trip time is actually a lot longer with like all the OPs. So that's pretty much the end of the demo.